Hi, my name is Alex Williams, founder of The New Stack, and you're listening to the New Stack Analyst Podcast, a show about application development and management at scale. Thanks for joining us. We'd like to thank Joyent, our sponsor for this episode of The New Stack Analyst. Joyent built a business on containers more than 10 years ago. Today, that bet is paying off with services such as Triton Platform, which is designed to run containers at scale. You can learn more about Joyent and its container services at joyent.com. Hey, it's Alex Williams of The New Stack here for another episode of The New Stack Analyst. This show is sponsored by Joyent. I want to thank them for being a supporter of The New Stack. And with us today is Zach Dunn. And Zach Dunn, I met at Container Summit, a Joyent event in Las Vegas, and we had a fun panel where we talked about Optoro and their efforts to use containers and the results of it. And Zach was a lot of fun on the panel, so I look forward to the discussion. And with me also is a co-host for the show, Ben Ball. Ben Ball is a technical editor at The New Stack. Zach, great to have you here, and Ben, thanks for joining us.
Thanks a lot.
Great to be here as always.
So the question about the economics of containers, it is a question that can both be abstract, but also has some real data behind it, right? We could probably look at, the differences, for example, in CPU usage when you use containers. You can think about also about volume, the number of actual containers on a host. You have to think about all these different issues and how they relate back to your own deployments and what you're doing. So Zach, can you first tell us about Optoro? Then I'd like to get into some of these questions, then perhaps talk about some of your experiences.
Yeah, so Optoro is a company. We're based out of DC, which is a little weird for a startup, but that's where we're at. And what we do is basically help retailers with excess and returned inventory, which sounds a little boring, but the sort of dirty secret of the retail industry is about 10 to 15% of every sale is a return. And that's actually going up because you think of companies like Zappos and everyone's got Amazon Prime now, and all these return, the real encouragement is buy it and return it if you don't like it, no cost returns. And that actually drives more sales. So these companies love it. But then the truth is they end up with a pile of merchandise they don't know what to do with. Not good at selling individual SKUs. If you're a larger company, you want to sell 1,000 MacBooks. You don't want to sell one used MacBook and try to figure out how to make sure it's refurbished and tested and graded and out the door.
Right.
And so the traditional method for this has basically been liquidation. And that's a very long tail process, right? Starts in a store gets shipped back to a regional warehouse, that regional warehouse ships back to a distribution center, the distribution center lets it pile up, eventually they get a couple of truckloads, some guy named Lou comes in, Lou's like, yeah, there's some iPads in there, but there's a lot of crap, I'll give you $2,000 for it. Oh no, I want 4, okay. And he buys this thing on spec. And they buy it, then he sorts it. This then gets out to places like Filing's Basements, these other larger liquidators, goes out again, gets liquidated, and eventually, say that iPhone 5 you return because the iPhone 6 came out, and obviously your iPhone 5 was trash. You took that, you returned it. Now 9 months later, it's getting back out to eBay or somewhere else. Well, in the meantime, it's lost a huge amount of value, and at the same time, it's been trucked around a lot. And the retailer got pennies on the dollar for something that was returned and was actually perfectly good. So what we do is we step in, we work directly with the retailers, we take those individual returns and excess inventory and list them immediately onto our own site, blink.com, also Amazon and eBay, and we move them, and we move them quick. We take a small percentage, and we get the retailer that final, probably higher price. And we keep a lot of crap out of landfills and a lot of stuff from actually just sitting around and losing a lot of utility for people.
So tell us about the history of the company and how it has deployed its infrastructure.
Yeah, so I think like most companies born in the last 5 to 6 years, we were born on the cloud. We started on Amazon. We started EC2 Classic. Not a real heavy user of the sort of ancillary Amazon services. No RDS, a lot of S3, and a lot of EC2 and EBS. Most of that was because we were a fairly traditional Rails shop. We didn't have a need for a lot of these things. We also ran some database technologies like Mongo, where there wasn't an RDS solution for it, so we had to run it ourselves. So we started off in EC2 Classic. We eventually migrated to VPCs. And then we kind of got to the point where it was like, okay, we've actually got this under control. We've got a really good chef pipeline. Everything that gets deployed gets tested. You know, we even do our deploys with Chef on our application servers. We've got this monitored well. We're using, you know, Sensu for monitoring. We've got this down pretty well. We got Terraform in there, so everything's written down in Amazon. And our business is growing and doing well. And so we kept growing in the cloud. And so we kind of kept spending more money in the cloud.
Right.
And so we kind of got to a point where probably about 2 years ago, we were at about a $20,000 burn. And then we kept growing up until about, I think it was probably January. We were at our peak at around 77 or 78. Because what we found is, as a retailer, which is essentially what we are and our customers are, you know, every November or so when we start with that Black Friday, that's our run rate until the end of the year. And because we've been growing, that run rate never came back down. So we didn't see that nice hump that some of the retailers see, where it's like, oh, I'm going to bring on my excess capacity and then I'll turn it off and see a savings. We kept seeing more cost.
Okay.
What exactly were these costs going towards at AWS?
So at AWS, it was almost entirely so our split was roughly, of our bill, about 20 to 25% was EBS, and about another 80% of the, about another 70% of that bill was EC2. And then we had the 5% that was VPC interconnects and IO. And when I say EBS, I mean with the magnetic storage and SSD and all that, the IOPS are included in that. And we actually had a lot of long conversations with AWS on how to improve that. And you know, they like to throw around numbers about the prepaid 3-year RIs. And they're like, this is a great deal. You can lower your bill by 60%. Well, the problem is it's a lot of money up front. And so what we found was it would actually have been a lot of money to get that 3-year cost. It also only offsets 60% of the EC2 bill. They don't touch your RDS bill. I'm sorry, your EBS bill. So we'd still have that nearly $15,000 to $20,000 a month in EBS. And that's it's a lot of money.
Right.
At least for a company our size, that was a substantial amount of money. So we might have been able to save, and I don't mean to make this sound insignificant, $20,000 or $30,000 a month amortized with that RI spend. But we still would have had a $45,000 bill every month. $45,000 to $50,000 again when we amortize that cost out, because you're still paying for the utilization of IO, you're still paying for the utilization of network and VPC and the EBS volumes.
And what percentage were the EBS volumes, would you say? Were they a big part of that cost?
Oh yeah, like I said, about 20% of our cost.
Oh, I see. Yeah.
In Amazon was straight up EBS volumes, and a lot of that is part of our technology stack is understanding what things cost.
Right.
We're selling a lot of used and excess inventory, so we need to know what it sells for so that we can price it correctly, which means we have to hold on to a lot of pricing data, and that's part of our value add to our customers too. A lot of our customers come back and say things like, well, yeah, I've got a bunch of Dell laptops, we bought 5,000 from Dell. We're on the hook to buy another 5,000 next time they come out. We've got 100 left. Well, you don't want to keep those on the showroom floor. And so they pull them off when the new laptops come out. But then the question is, well, what are these things worth? Now, we do a lot of pricing analytics against the market itself. But then we also know, hey, we sold one of these last month. We know exactly what it's worth as a sort of a B grade. So it's like a return, or if it's new in box, we could tell you what it's worth. But we end up keeping a lot of that data for historical purposes. And because we're having to actually use it very aggressively, we found that as our business grew and grew, we had to migrate off of the magnetic volumes. So we had to go to the SSD-based volumes. And there's a pretty big price drop there.
Okay. Okay. So tell us about your kind of your technology architecture at the time and and how you were thinking about that, as far as your overall infrastructure was being deployed.
Yeah, so we had a bunch of EC2 volumes. They're running out there, mostly app servers sitting behind ELBs, or in case of one or two of our products, HA proxy. And then we were talking to pretty traditional RDSs in Mongo, and we started down this path of, we kind of built a monorail. It was this huge Rails application that really between all of the gems that were included and everything else, you're looking at each thread being about 300 megs. It got substantial. It's thousands and thousands of lines of code, and it became not just for the infrastructure group that I manage here, but also for the developers, this cognitive load of understanding a very complicated piece of technology that has these sort of spooky actions at a distance, right? Like a unit goes in and magical things kind of happen in the background, and then out comes a sale. And in between, there's all this business logic that's encapsulated in there. So at that point, we started to realize we couldn't, basically this bag of shit was full. We couldn't put any more in there. So we started down this service route. And that's where we sort of stumbled on this idea of this, I think what the rest of the tech community around containers being really valuable here. We started getting into a position where we were not going to be launching anymore, trying not to launch much more around our principal Ruby application, but instead breaking out new functionality into services. But now we had a problem. Before, we're running 400 EC2 instances. And that was pretty good. I mean, we're chugging along pretty well. But each new service meant we had to have tiers for it. So we had a QA tier, a staging tier, and a production tier, roughly. And each one of those, of course, everyone wants to have their staging tier look like production. So we want HA. We want a little bit of capacity. So maybe you launch 2 to 4 instances if it's not a very, very busy service. But then I have the databases, maybe some caching. Roughly, these things started to look like 10 or 20 containers per tier all of a sudden. I mean, VMs per tier. So now every time we launched a new service, we had this pretty big little bump, like a 10% bump in our, a 5 to 10% bump in the number of VMs we were simply running. And that got to be problematic, right? We're adding more and more load into the system. And again, we're watching our bill go up each time.
What was the cost involved in increasing those tiers?
So I mean, it's a hard question, right? Because at the one level, the cost is pretty easy to look at. Amazon's charging me, maybe $500 to $1,000 a month extra. I'm watching my bill trickle up. We saw our bill increase about 2% a month. That was our going run rate, and that was month over month. So if I was 10,000, 10,200 the next, and then I was 302 or whatever that comes out to the next month. So it was compounding, and it was starting to hurt a bit. But then of course there's the argument of, but we had environments where people could do their jobs. So there's certainly a lot of value in being able to give the resources to people to be able to do their jobs. We want to catch things before they go to production. I need something where people can break stuff. So I need a QA space, right?
Does that have anything to do with your original experimentation with containers? Was this something where you were utilizing it in a couple different ways first to experiment with it, or did you kind of launch into containers full force?
Yeah. So it's funny. The first place we tried containers was an utter failure, and that was testing. We tried to launch our Chef infrastructure and our applications inside of containers. And it's not that that Docker failed us here in this case. It's that it in no way actually mimicked our production environment. Our production environment wasn't containers. Our production environment was Ubuntu LTS that had been out running for a year with Chef running on it, and Sensu and Logstash and a lot of different environments. And we would do configuration changes along the way. And those things weren't getting back into those Docker containers. So when we were testing stuff, it's like, yeah, all looks green in my container. I'm going to push production. There's a fire in production. Great. What's the problem? Oh, yeah, I didn't know you guys didn't have that package there, or I needed this thing. So what that really pointed at us is we had this real decoupling between trying to use a container for one thing if it didn't actually match what was in production. And you know, I'm a big fan of stability, being sort of from the ops tribe. You know, I like my pager not going off. So we kind of said like, yeah, kibosh. Like, you have environments. We have these all-in-one instances where you guys can run stuff. We need to not break production over anything else. But when we started doing these services and we started looking at this, we're like, this is from scratch. Like, why are we reinventing this process? And even I think what really started to happen, sort of getting back to the efficiency and economics of it, our DevOps group started becoming a bottleneck. If you wanted to get a service out the door, you needed to get time on my roadmap so that we could build out the infrastructure for you. So that
even more so than you'd have someone to help deploy a VM?
Well, so not with containers. But
I know with containers, but how's that cost compared to like when you're using VMs and you needed people to help them manage that?
So we've shifted that cost a bit. So now instead of having gatekeepers, we have tool builders. So instead of having a team of people who are going to take tickets, and it says, you know, build me a Ruby environment and build me 3, and I need a Postgres database to go with it. We have a team, and we have a tool called Hammer, because every problem's a nail.
Love it.
Yeah. So we're Rubyists, man. You give them a theme, they're the dog with a bone. So we now have people who are building tools instead. So the idea is we have a tool, and the goal is to make your laptop look a lot more like production. So we have a fairly agnostic platform. We don't run Kubernetes. We don't run Mesos. We actually launch native Dockers. And we use console for service registration.
Mm-hmm.
And we actually will launch all of that onto your own machine. And then when you go to launch to production, it's simply looking for registrations and looking for whether or not these are the newest versions of what should be running. If not, we relaunch, blue-green, pull down the old stuff. So in that case, this has worked really well for us, because now I can file bug reports. I can say, we need a feature here. We've gotten more into the world where our feature developers, understand that if the tool isn't doing something they want, well, they know how to work with that. They've been working with that in their own code bases. They know they need to do a pull request, or they know they need to get a feature implemented. And now we can have conversations around the priority of getting that feature out, whether it makes sense. And there's a little bit of a social hack here too. We're going to slow down experimentation to a degree. You're not just going to be able to launch an Elixir VM or an Elixir container because you think it's something cool to try and build a production service on it. It needs to be something the tool supports. So now we kind of force that conversation of what should be running in our production environment and what should be paying my mortgage. Because I think, like a lot of startups, a lot of companies out there, something cool and shiny comes along, you give it a shot. Hey, it works well enough. It's an experiment. And then no one ever really finishes the experiment or rolls forward with it. And so we actually saw a lot of cost on our side before moving to containers with this experiment creep, this technology creep of trying things out. It was a neat experiment, but then throwing it away and never actually bringing it back into the fold. So now that we have a tool and a pipeline that sits on people's laptops, we're actually controlling that sprawl a lot. So there's a real savings operationally there that's hard to quantify, but is actually very real for us.
So I have a question about your staffing then.
Mm-hmm.
And you had a lot of people who originally were Ruby developers. You had people who were proficient in managing tickets, right? Has your staffing changed, and has that had an economic impact? Or no, is it just a matter of new skill sets you needed to teach people? And what has there been what's the investment around that?
So I think this is the great irony of sort of DevOps and all these technologies. We're all generalists. So this is just new skills for us.
Mm-hmm.
This is no different than folks learning how to use IPMI,
right?
Manage a server remotely. There's a little bit of a transition for some folks because they're slightly more used to thinking of themselves as infrastructure people, and less living in a code-based world. But this was the same struggle I saw with configuration management and moving people towards TDD around that. So really what we've seen is it's a shifting of skills, but at the same time, we made the decision at Optoro to move on premises. And when we made that decision, we also got to take advantage of the fact that we had people with infrastructure skills, and we could take advantage of those skills simultaneously to sort of changing how people work with our infrastructure.
So considering that was still new skills being acquired, and I'm going to imagine containers was probably still kind of a new concept for probably everyone involved.
Yeah.
Was it just this ability to experiment that motivated this, or was there an understanding that this might lower costs up front?
So yeah, I think we had two things. One was so the team who works on Hammer, we refer to it as a platform team, and the platform team's motto is it's a greased ballistic rope factory, which is just enough rope to blow your foot off.
It's a what?
Just enough rope to blow your foot off.
But it's a what factory, you said?
Oh, a greased ballistic rope factory.
Oh, okay.
So the idea is that we should be producing this tool that lets you go very quickly and blow your foot off if you use it wrong. But at the same time, that doesn't sort of like let us get out of the fact that there are people who have skills that let them help the rest of the company get along. And this is sort of like DevOps 101 stuff, right? Like we all own production. We need to actually take that seriously. One of the things we found really frustrating when we got into the container world and started to cause us a lot of real concern around it was it's very easy to launch these containers, but you've launched a perfect black box. There's very little telemetry. There's very little good operational stuff in general, right? The things that gave us warm and fuzzies about how our infrastructure was working and running, those were missing. So we've been actually very active in going back and figuring out the best places to poke those holes. I'll be completely honest, we violate the Docker tenets of running only one process inside of a container. We are those heathens. We run a supervisor, and we do launch multiple processes.
And so why do you do that?
So a lot of it comes down to things like we have applications that we want to run that they weren't really meant to run in containers. And so we
like
want
what?
So take, for example, if I'm going to run a Postgres on your machine or a MySQL, those logs are terrible. They were designed for the late 90s. They were not designed to be parsed. They were meant to be human readable. And so we're not just going to string those off. We also have then the problem, a certain struggle around just logging in general. I love logs, but now I'm just going to let every random person decide on what format they want, where they're going to go. So instead, we use Supervisor D to launch these processes. We actually use Container Pilot with that. And then with all of that, we're taking those logs and then sending them off to Kafka. And then from Kafka, we can process them however we want. And we have some certain contracts and tenants around that, right? Like you're going to log in JSON from your application. Oh, I know that this guy is, I'm taking Memcache logs or I'm taking Redis logs, and they're unformatted, terrible, bad. Okay, put them in the I know how to parse those. Same thing for metrics. Because we're using Container Pilot, we get the C advisor stack. And so now we're implementing some of the like node exporter and some other things so that we can start to reap some of that out. But again, with that grease ballistics rope factory metaphor, this has to be something that is very transparent. And it has to be something that also doesn't take a lot of cognitive load to get started. So one of the things we do is we register these machines in the console. We expose what metric endpoints are running on that. We help Prometheus, and Prometheus starts scraping out those metrics for us. So if you launch a service into our environment, you're going to get metrics, you're going to get logs, and you're going to get an IP that you can go to immediately.
That's the critical kind of path toward telemetry, isn't it?
Yeah, and this is the sort of stuff that sort of just rattled our cage when we got into this Docker world. None of that was there.
Right.
And there was frameworks that gave you some of it, And I think people are getting better. I mean, this has been a year plus quest for us.
Okay.
So, I mean, think about how many Docker technologies have been introduced and gone away in a year.
Right.
So this was our own sort of stake in that.
I guess that raises the question, there's a lot of talk about, the direction of Docker, right?
Yeah.
And, there's talk about, in extreme cases, an actual fork. A lot of people are talking about the issues that end users have with the changing, as Docker, goes from version to version.
Yeah.
How have you guys been dealing with that challenge?
So in a weird way, we've been kind of isolated from it.
Mm-hmm.
We don't use a lot of the fancy stuff in Docker.
And like what would you call fancy stuff?
Well, so like we don't do any of the mesh networking. We don't do any linking. We don't do data volumes. We really have avoided a lot of that. One, because there's this sort of like co-location of resources problem that comes with the data volumes. But also we have IPv4, and that works really well. And our containers get proper IP spaces. We run on Triton. So we don't actually need a lot of the things that are kind of shinier and more new about a lot of these. What we really are looking for is a deployable. I think back to like a WAR file or something. I want this completely built binary package that I can just deploy anywhere. And then on top of that, I want to be able to essentially make this work anywhere. And so for us, that's been really the key, is someone can build this on their laptop and then they can deploy to production. And it's boring.
So that has to be an economic consideration, and just, forcing you to keep it simple, doesn't it?
Yeah. Oh, absolutely. And this is one of those things where, some of this has been guided by the technology we chose. But a lot of it is just straight up economics, right? Like, so we were spending $76,000 a month. And we knew that that's a lot of money for us. So we said, okay, we did the math. We can lease, some servers, some data space, install and run our own stuff. And now we have a run rate of about 22. And I bought twice the capacity I was running in Amazon. And one of the things that really kind of hit home for me the other day when we were looking at this is we've finished our migrations up. We're pretty much 100% off of Amazon at this point. And we are running about 500 VMs. And that was on Friday. And I came into work on Monday, and we had gone up to 530. And I'm like, what the hell did we just launch over the weekend 30 more containers for? And it's, people are just, they're trying out new things. They're experimenting. They're building services. And I think back, if we had still been on Amazon, man, I saw an 8% bump over the weekend, or 7, whatever that works out to be, in my bill. We'd start to get sort of concerned. I'd be concerned about that. If that's what people are going to do over the weekend for fun, does that mean I end up now with this container sprawl problem? And this is, let's look at our history. We had this problem with VMs. Everyone thought, we were going to take these data centers and we were going to condense data centers down to single racks from tens of racks. I remember taking those tens of racks and turning them into all VMware or whatever your virtualization choice was at the time, and filling them. So I think that the truth is that technology abhors a vacuum, and if you give developer resources, they're going to use them.
Yeah,
like they should. But even more so, kind of getting back to it, because we chose to be sort of container native on Metal. This meant that our use of CPU was more efficient, so I can run fewer CPUs. I can do better bursting. I also run smaller disks because I'm running these sparsely allocated disks. We're also using LZ4 compression underneath the hood because we're on top of ZFS. So I have, a real life example, we have a Mongo dataset in Amazon that was a 5.9 terabyte volume. We're running that on SSDs. So if anyone's ever run large SSD volumes in Amazon, it's a cringe number. Right? You're like, oh God.
Yikes, ouch.
An 8 terabyte SSD from Amazon. Oh. So we were running that data set, and it was Mongo 2. which has a whole host of problems with basically having no concept of vacuum unless you take the node offline.
Right.
And, so there was a lot of dead space there. So we migrated to Mongo 3, and we migrated to that into our own containers running on top of ZFS. And we took that nearly 6 terabyte volume down to 800 gigs. Now that was technology because Wired Tiger and Mongo is a hell of a lot better than their 2.0 engine ever was. But we also get about a 2x compression ratio. And I'm also not running an entire OS for each one of these machines anymore. So if you think back to your Amazon EC2, if you're running 500 VMs, you probably have about 508 gigabyte. If you're
Right.
on Ubuntu, 8 gigabyte EC2 volume sitting out there now.
Right.
And then you get to actually install your other data volumes and move on with your life. So we certainly saw a huge efficiency change just from shifting our mindset into these containers. But there's some places where we're not using or may not actually use containers entirely. I don't.
The horror.
Well, I know. I'm not a purist. It's kind of crazy, and this is actually one of the reasons why we ended up not choosing some of the Docker frameworks that are out there. They were a little too. Everything needs to be a container for our liking. So our databases, MySQL wasn't exactly built to run inside of a container.
Right.
It's really not that good at it. If you end up running MySQL sort of in the traditional Docker pattern, which is funny to be able to say that, by the way, because I feel like Docker's a new technology and saying traditional, maybe prescribed is the better term. We'd have a bin to run it. We'd have a data volume. I guess I'd have another one for cron because I like backups. I'd have something to run the logs off of it as well because I need to know what's going on, and possibly another one because we run something like Vivid Cortex. So maybe I have 5 Dockers to run my database now.
Mm-hmm.
Well, they all have to be co-located. And it kind of sounds like you wanted processes. So we have this really good thing for processes. It's called user space. And we're okay with running that inside of an LX branded zone, which is, to be fair, a form of container.
Right.
We're just not using the Docker format. But that's been sort of our in-between step. We're getting off of VMs for sure, but whether you go to a Docker container or an LX branded zone or a SmartOS zone is the question.
Let's take a quick break for a message about our sponsor. We'd like to thank Joyent, our sponsor for this episode of the New Stack Analyst. Joyent built a business on containers more than 10 years ago. Today, that bet is paying off with services such as Triton Platform, which is designed to run containers at scale. You can learn more about Joyent and its container services at joyent.com. Now, let's get back to the show.
So I have a question here. We talked about your beginnings on AWS, and even starting with containers on AWS, or probably those first experimentations. When you actually did migrate away from AWS to your own infrastructure, what exactly did that infrastructure look like? What exactly were you migrating to, I think?
Yeah, so we have a small data space. We have 2 racks currently, space for 6. We do 3-phase, 30 amp power dual into each rack. We do about 30 servers per rack. So right now we're running 42 servers, and those are dual core machines with 256 gigs of RAM and 12 SSDs. And then sitting on top of that, we do 10 gig switching with some Aristas, and we have some full GigE pipes that come into that from our provider info relay. Sitting on top of that, the software side of that is Joyent's Triton. So Joyent actually did this kind of really cool thing and open sourced their entire platform, I want to say a couple years back. And that's what we actually run natively. So that's the OS is interesting here because it's runs off a USB stick. And then once you have the orchestration layer in place, which is really just a number of smart OS zones. Once you have all of this in place and you've built out the infrastructure around it, those machines just pixie boot the compute nodes, come up, and they are ready to be ready to have machines launched onto them. What Joyent did that was, I think, also kind of very clever is they realized the Docker daemon was really just an HTTP daemon, HTTP API. So they implemented that API as a service, and then translate those calls into provisioning machines on their infrastructure. So what's really cool here is we don't have Docker daemons running on each one of these compute nodes. In the background, what's happening is the Smart OS starts an LX branded zone and then runs Docker init inside of it. So our Docker images actually run inside of an LX branded zone, which is sitting on top of an Lumos-based kernel. And then all of that is actually sitting on top of a ZFS file system, which is where we get our LZ4 compression. We get snapshots. So we get a lot of sort of these great benefits. But I'll be honest, we get some downsides too, right? Like the Lumos way of creating zones. This is a derivative of Solaris. Zones are very, very, very well engineered. They don't allow for things like the Docker socket. The Docker socket does not exist. And this has actually caused some of my developers, let's call it some grief. Because what do they, I think a lot of what happens is people go and they Google around and they're like, oh, well, I'll just install Datadog onto each one of our nodes and then we'll start getting metrics. It's like, oh, cool. How does that work? And they're like, oh, well, you install on the zone, you make it a privileged zone, and then they can see the Docker socket and they can then issue these queries into all the other Dockers. And you're like, it doesn't exist. Sorry. So there's definitely.
What doesn't exist in particular?
The Docker socket.
Right.
We don't have the Docker socket. So we've hit some interesting sort of challenges with that. But yeah, in our own world, we have roughly 42 machines that are all individual hosts. We don't have any network storage, so it's all local storage, which has its benefits and its drawbacks. We certainly get just a much, much better performance profile and consistent performance profile on our own gear than we ever did in Amazon. We don't have so many issues with steel as we did on sort of smaller services like Redis, which we are a pretty big user of Rescue. So we would hit a lot of issues where Redis would slow down because the box it was running on was issuing about 50% steel against that VM. So we had some issues with that before, but we also get very consistent disk I/O. ZFS is perhaps not the fastest thing in the world, but if you shove 12 SSDs into a machine and make it a RAID 10, it makes up for it pretty quickly. So we've seen a real nice, consistent, predictable performance pattern out of that.
What guided your thinking when you chose Joyent Triton? Just wondering if there was something where you considered other options, or if you were thinking about other possibilities for implementing this.
Yeah. So one thing was definitely, we did look at doing something like a Mesosphere, just on bare metal. There was sort of a complete buy-in that needed to take place to make that happen, at least at the time. So the thing that pays my mortgage when we were going into this adventure is our application. Our application is not container native. It's not ready to be shoehorned into that. So again, because this conversation is about economics, just think about it. I would have continued to have this $76,000 burn rate in Amazon while taking on a new burn rate of 22 or so thousand to run the data center. And I wouldn't have had a very clear migration strategy. My migration strategy at that point probably would have been something like, well, everybody, you need to relaunch your stuff in containers. And you need to go ahead and do that. And that was a hard sell. So instead, what we said is, well, what if we had something that could do containers and KVM and whatever else we needed to do? What if we found something that was a good solid base? I've worked with a number of these technologies before. So sitting down and looking at this and saying, oh, we could do Cloud Stack or OpenStack or something like that. They're okay. But I know from experience using Joyent in the past and sort of the Lumos internals, that's a really solid platform. And so being able to have the flexibility to say, hey, you know what, right now we're not going to run Kubernetes, but I'm going to build an infrastructure that can. And if we want to run that later, we can do that. But right now, I can change our burn rate from 76 to 22, and we can start down a path of talking about what makes the most sense for us. And now we have the flexibility to do that. So if we wanted to go with a mesosphere, great. I can run one agent and one master and tell that agent that its Docker endpoint is the join endpoint. Now it thinks it has a host with 8 terabytes of RAM. It'll just launch things against it, right? And now those are all container native, and I'm using the Mesosphere API and some other things like that. But there are one of the biggest calculations in economics, and I think this is one of the things that kind of comes up a lot when I speak to people about migrating off the cloud, is this sort of imaginary, or not, I guess imaginary isn't the right word, but a very hard to quantify return on investment or opportunity cost. So what's the opportunity cost of doing these things? The truth is you're always going to be doing something, and you can make that opportunity cost favor either selection. It really depends where you want to end up. We wanted to end up as a container native company. We want to enable people to go as quickly as possible. We want to be able to get the most bang out of our resources. So at the end of the day, that read like containers on metal. And so we needed to plot a way to get to that end goal. And we couldn't kind of skip steps, right? You couldn't say, well, we're just going to make everything for Blink and Optoro and Bulk run inside of containers now. That wouldn't have worked. And we would have spent a lot of time and engineering cost up front to have this big bang cutover. And I've never worked on a project where a big bang cutover resulted in anything but pain. So instead, we could take this nice migration path and go, oh man, I can't get this to run inside of a container. It doesn't want to run in an LX zone. Cool, we'll launch it as a KVM. We'll put it in the backlog. We'll come back to it later. We don't get the better. We get a nice performance profile. Yeah, we're not going to get the sort of sweet bare metal performance we want, but we can move on. We can get the rest of the stuff that can to that state.
I guess one of the things that I come out of this conversation is how really the need really is to have something solid, right? You need
Absolutely.
At the end of the day, it doesn't matter if it's a customized, infrastructure or not. You need something solid.
Yeah. And I think there's something to be said for, certainly our tipping point was when our burn rate hit about 40 or 50,000. We started looking around because of just the pure cost, but we weren't going to move to something that didn't work. Like that's table stakes for all of this, right? Like no one's going to say, oh, well, great. I'm able to cut my bill in half and shit goes down every day. Like that wouldn't work, right? So definitely table stakes in this was we need to be able to be as stable as Amazon. That's and I'll kick Amazon every once in a while. They're big enough. I think they can take it. And they have had stability issues in the past, like we all have. But on the whole, they offer a really good product. Most IaaSs do. So the where we as a sort of a technical community get into problems is the things we run on top of them. So the APIs and the data stores and the things we've built to go along with it.
So one of the things when we did this panel at Container Summit, you were talking. One of the memorable points when you started saying how you realized at one point that you were sending Jeff Bezos a really nice BMW every month.
Yeah, that was a moment.
And now you're able to cut hosting fees in that time to $22K recently, and double your stack, switching to an on-prem solution. Is that model? Do you still see those numbers? Are they better? Are they what any change in that?
So we're so the only real change we've seen in our numbers so far is we're about to hit our power cliff. So our numbers are going to go up a bit because we get more capacity in about 6 months. But right now, that's been the honestly one of the biggest wins from an accounting point of view, just straight out in economics. I write the same check to our hosting provider and our leasing company every month. And I literally bought, so we looked at Amazon, we totaled up number of cores and RAM and disk used. I went out and bought twice as much of that. So it's not even apples to apples. We were running on machines that were gig Ethernet, magnetic storage, some SSD, some 10 gig. We're all 10 gig. We're all SSD. We're all the same CPU frequency. So we bought twice as much as we had in Amazon. And that actually, I'm very proud of the fact that we hit those numbers. If I go into my dashboard right now for our Triton installation, we're using 50% of our capacity. And that's actually including a 10% reserve, 15% reserve that Triton by default installs. So really, I'm using 35% of the capacity I bought. And that 35%, that 15% delta is honestly mostly because of our container strategy. That's been the biggest win for us. We're not running all those host volumes. We're able to run machines that are slightly smaller. I wish I had I have a pretty good graph that shows our MySQL utilization. One of our principal databases at MySQL box. We were running literally the largest machine Amazon would sell us at the time, like the M2 10X large, like 192 gigs of RAM and 40 cores. So we basically gave it a whole box inside of our data center. That's a little smaller than one of our hosts in the data center. We created something that looks very similar to that, gave it that. And our load utilization on that machine during the day would go up to about 20 or 30, come back down. It was very much followed our normal business day. And we don't go that high on that machine anymore. We've really bought capacity through efficiency. And that was actually something that was really nice about this sort of container. And in this sense, I'm talking about an LX zone. I'm not talking about a Docker container. But being able to have that bare metal consistent performance actually means we've bought scaling. We're a more efficient, we've made a bit of our infrastructure more efficient by doing that.
How does the investment in your infrastructure actually affect other decisions you make in your business? Is it something that's allowed you to do more elsewhere?
Yeah, I mean, certainly if I tell sales guys you have to make $720,000 less in sales this year, they're pretty excited. Or we just say, hey, look, that's straight to our bottom line. We're not spending that money. The business is really excited, and they're going to go out and they're going to pitch deals. They can be more aggressive on pricing. We also are in a position where we do purchase loads sometimes as a liquidator. So that certainly gives us a lot of flexibility. It also gives us flexibility to look and invest in services that we think we can take advantage of. The thing that I get asked a lot about this is, yeah, but now you're on metal, you're on premises. What are you going to do when you need to expand and you have to order a rack of servers, right? And that was actually one of the biggest conceptions when we went through this process, that people seem to think that the only place you can have an API-driven infrastructure is the cloud. And the truth is, you can have an API-driven infrastructure on your own on-premises. We also, one of the decision makers for us for choosing Triton was that I can use Joyent's public cloud now, and I have the exact same API as I do for my private cloud. So if I need extra capacity, I just start spinning stuff up in Joyent. And then I turn around and I order gear when it makes sense. So if we're coming into the holiday season, I need some extra application servers, or we want to do just some more worker boxes, great, spin them up in Joyent. We have a connect with them, watch that stuff work. We don't need them anymore, kill them, take them back. It's like we can use it for elasticity and not just steady state.
So I guess the question I have is, like, I've heard people say like they've thought about making an investment in their own infrastructure as opposed to using Amazon, but they decided to make investments otherwise in other parts of the business. So, and Netflix is a good example of that, right? Yeah. They've stayed on AWS, and they did that because they didn't want to invest in their own infrastructure. They thought that money could be better spent elsewhere. Yep. And now they're basically in the studio business, right?
Right. Oh yeah.
So
And
I'm
I think,
curious on your thought, where you guys were thinking and what have been some of the, trade-offs that you did have to make.
so definitely, we had to push some work. I had people that were learning about how to run Triton. That's a sunk cost though, right? Like once we've learned it, we're there. The other thing is for us, we spent less money here. So we were able to take that money and invest in other things. I think one of the things with Netflix is they still run a huge data center presence in terms of their CDN. All of their movies are actually delivered from hardware. It's their API, and I'm not trying to belittle the amount of gear they run. They run a huge amount. I think that at the end of the day, it really does come down to what your business is doing. I look at cloud as a great place for burst capacity, but it's cheap for us. It's cheaper to own than to rent. I think that the idea of being cloud native doesn't mean you're sort of stuck on a vendor. It means that you're building things in a way that all of this is triggered through APIs. You're allowing yourself to adopt a pattern like the autopilot pattern, and you're looking at more things like making more of your structures immutable. I mean, I don't think that any of that says I have to be on Amazon, I have to be on Azure, I have to be on Google Compute. It's just a pattern. And there are still companies who run on Metal, right? I think it was Box or Dropbox. I can't remember. I always just confuse them because they both have the same word. Who just moved off of it, finished moving off of AWS.
Yeah.
Again, I think this is going to be something that everyone looks at and decides themselves what's the best economics.
Right.
And one of the things that drove our decision was myself and two other team members had a lot of experience running infrastructure. We had those resources. We could leverage them. If I was working in a shop where no one had experience doing networking or running hardware, it would be a much harder conversation. There would have been a lot more investment we'd have to make into people, and when we're making that investment, we're implicitly not having them do other work. So we were actually able to leverage resources inside of our company to better take advantage of the people we had. And that's not always going to be the case for everyone.
You mentioned being able to spin up additional application servers if you need it. Are you expecting a lot of growth this year or the coming years? Is this something where you think you're actually going to be growing a lot and this is going to be something that you're adding on to a lot?
Yeah, I mean, so the thing that always bit running anything in a data center, and this is always the argument for the cloud, right? Is in the cloud, you're only paying for what you use, and in your data center, you have all this waste, all this unused capacity, because it's it's such a long cycle to get hardware in, right? So you have this very stair-step function of bringing capacity into a data center. We're no exception to that. We have 2 racks. When those 2 racks are full, they're full. We need to bring in more capacity. The beautiful part about what we've got is we're still growing and we're launching just too many damn containers every day. As we grow, we're going to bring in more racks. But in the meantime, I don't have to tell my devs, hey man, don't do your job today. Don't launch anything. I tell them, hey, in Hammer, how you can tell it to do that in our Triton? Yeah, use the public Triton today, okay? Cool. Now I can still talk to everything. Don't worry, bro. And move on. And so I can go to 110% of capacity, where that 10% is really running enjoyment. Bring in our own gear, and because again, we're encouraging that, hey, your stuff's immutable, right? Tell them they need to relaunch their stuff. Hey, it hits our internal Triton. It sees that it has new capacity. It launches them on those new machines, and we blow the ones away that are enjoying. So in this way, where I think people really tripped up with this hybrid pattern before was like, crap, I've launched this application server and now it's in Azure and I can't pull it down. So I guess we're just gonna have this Azure bill now forever. I don't know if anyone actually has Azure bills, but maybe they do. So I guess Amazon would be a better example. But so I'm gonna have this Amazon bill now forever because I'm not actually gonna pull this thing down. The containers and being container native actually lets us say, oh no, blow it the fuck away. What are you doing? It's immutable. Just launch it again on our stuff. And when it registers itself in console, everything else will get its new IP, and they'll adjust their traffic accordingly. What's the big deal? So one of the things we've really taken away from this experience is you have to be able to let things, this autopilot pattern of basically letting self-discovery take place, hugely important. It makes this process so much more easy.
Yeah.
However, we're still all figuring that pattern out. I think there's a lot of really good examples how to do it, but there's a lot. Again, it's ballistic rope. You're gonna blow a finger off every once in a while, and you're gonna be like, oh man, yeah, I shouldn't have a console watch on my MySQL connection because I just restarted all of my servers when I did that. Right? Like, and you'll do that. You will absolutely do that. You'll say, oh yeah, I did a deploy. The site's down. What are you doing? It's like, no, I'm just doing a deploy. It's like, yeah, but you took out all the, the Memcache nodes or whatever. And just like, it is in some ways we're going back in time in some respects. I think there's a real value to it, and I don't think we would be doing that work unless it actually did provide A, economic savings, but B, it provides a business advantage. We are spending less money and moving faster than our competition.
And the patterns continue.
Yeah. That's what it's all about, right?
Yeah.
Look, it was all solved in the 70s.
That's right.
I've got at least another 30 years of making this stuff look like it's new. Cut me a break here, man. I got kids to feed.
That's right. They don't know that. They don't know anything about the 70s.
Exactly. That's why you got to always make sure, you're just reinventing a little bit of it. Don't make it look too obvious. Yeah, no, I mean, for us, this is still a work in progress, right? I've still got plenty of KVM. I still have LX zones that we're looking at going, those should be containers. I've got teams who are looking to launch things, and to be honest, are just like, I don't want to care about my OS or building you a Docker package. So there's I thought that when we started this, in some ways, the developers would be the biggest cheerleaders for this, our feature developers, and there's a real split inside of our company about it. And I found that was really exciting to me, because there's people who are just like, no, I don't want anything to do with this. I just want to give you code, man. And others who were, yeah, of course, like, I'm going to go ahead of the curve here. I'm going to do stuff outside of Hammer, and yeah, I promise I'll backport it. That's what it got.
All comes down to the individual in many ways.
Absolutely.
Zach, thank you very much for taking some time to talk with us. It's been a really good conversation. It's helped me kind of understand a lot more of the nuances of thinking through how you're going to be deploying your own container architecture, whether that be on a service or not. So thank you very much.
Hey, thanks for taking the time.
And Ben, thanks for joining us, being co-host for the New Stack Analyst. I'm Alex Williams, the New Stack. We'll be back again soon. We'd like to thank Joyent, our sponsor for this episode of the New Stack Analyst. Joyent built a business on containers more than 10 years ago. Today, that bet is paying off with services such as Triton Platform, which is designed to run containers at scale. You can learn more about Joyent and its container services at joyent.com.